All right, so we're joined here today by Jeff Adams. Jeff is one of the earliest voice pioneers. This is going to be a really special episode because we're going to talk a whole lot about the science that goes into Alexa and these different consumer smart speaker devices and voice assistants as a whole. But before we go into too much depth, Jeff, why don't you tell us a little bit about who you are, where you're at now with Cobalt, and then maybe just a brief synopsis of where you were before you went off and started Cobalt.
Sure. Thanks, Dave. By the way, I'm glad to be here and always happy to talk about voice. Um, my main job these days is I am the founder, owner, and CEO of Cobalt Speech and Language, which is a company that does speech and voice and language related technology for all manner of applications and devices. And we're hired by other companies to help them build things mainly. So you wouldn't necessarily see our name on things directly, but our technology is behind stuff that you might see elsewhere.
Yeah.
And we're well. Let me just say a word or two about Cobalt. We're about 30 people strong, scattered around the world. We're a virtual company, so here we're recording this right in the time of the coronavirus quarantine, and that's it's kind of business as usual for us. We're all used to working from home and in a virtual setting anyway. Before I founded Cobalt, which would be going back like 6, 7, 8 years, I was involved at Amazon in the Alexa speech team. Alexa had acquired the speech company that I worked for before that, and so I and my team became the nucleus of the Alexa speech and language team, and we spent 3 years there building what became a surprisingly ubiquitous product. And that was a super cool experience, a lot of fun, and a lot of cool technology went into that. And going back further than that, I've been doing speech and voice technology, mostly speech recognition kinds of things, for just over 25 years now, and have worked in a number of companies doing a lot of interesting things.
Yeah, I remember when you were on the VoiceBot podcast with Brett, you guys went through a really extensive background, and I remember thinking to myself, "Wow, this guy has he is one of the OGs in this space. He's been around for a while, and he has like really chartered a path forward with this whole space." So it's super cool to have you on today. And for the audience, the reason I wanted to bring Jeff on is sort of twofold. I want to first set the stage of what the second half of the conversation is going to be. The first half is going to be about how we got to now with voice technology. I want to hear from somebody that knows the science of it and the domain expertise as well as Jeff. We just came up on Alexa's 5th birthday. And I want to hear how some of those initial challenges when he started at started at Amazon, how they solved some of the challenges that existed at the time, and then looking forward into where we're going with this technology. And in particular, how voice technology can be used in today's setting with coronavirus. How can we use voice technology to combat that? And I think if we have a better understanding of how we got to now, then we can kind of understand what the technology is capable of today and then 5 years from now with what's on the horizon. So Jeff, before this call, I sent you over your successor, Rohit. I sent the article that he penned after Alexa's 5th birthday, and he said, enhancements and foundational components of Alexa. He said, in order to be magical at the launch of Echo, Alexa needed to be great at 4 fundamental AI tasks. And those tasks were wake word detection, automatic speech recognition, natural language understanding, and text to speech synthesis. So can you kind of like walk us through like what that was like when you first started at Amazon And when you got pitched on this idea of, a smart speaker, far field microphones, can you walk us through what the mindset was like then, and then go through each of those four and say sort of like how wake word detection, automatic speech recognition, NLU, and text to speech synthesis have sort of evolved since then?
Yeah. I've mentioned this several times before in different settings. It was a little bit alarming for me when Amazon first brought us in, and finally, after we agreed to take part in some mystery project and sign up for 3 years, they brought us in and they finally told us what it was that they wanted to do. And I was a little bit alarmed because the conventional wisdom at the time was that what Amazon wanted to do was just not possible, at least not with the technology of the time. And and so there were things that we had to invent, develop, and it wasn't all invented in-house by my team. There were a lot of smart people working in academic settings, and we built upon their work and consulted with them and so forth. But it was a non-trivial task to develop those four areas that you outlined, to get Alexa to be able to work. And that's not even looking at the hardware side of the array microphones and the signal processing and so forth that goes into that. But let me take those four areas that you mentioned. I'm going to combine the first two for a second because they both have to do with speech recognition.
Okay.
The serious challenge that we had to overcome, the thing that was, let me say, impossible at the time. I mean, we've since solved the problem, but the thing that we didn't really know how to do was recognize speech that was coming from quite a distance, specifically indoors. The problem with being indoors is that you're in a room with lots of reflective surfaces. And so when the microphones pick up your speech, they're picking up many different copies of what you said. One copy is going straight from your mouth to the microphone, but there's also a copy that's bouncing off the window, and another copy bouncing off the desk, and another copy bouncing off the wall, and whatever. And each one of those arrives at the microphone with a little bit of a delay based on how far it had to travel in its bounce. And also with a little bit of distortion based on whatever it bounced off of. And so instead of just getting one simple copy of your speech, which was what all speech recognition at the time was used to, it had to deal with this muddle of 5 or 10 different copies of your speech, each one slightly delayed and distorted, and then all combined together. So that was really hard. That was the part of what was really hard about this problem. And that applies both to the problem of recognizing a wake word, but also recognizing the speech that's going to go with it. Let me tell you just a little bit how we tackled that problem. If that problem had been presented to us 5 years earlier, we would not have had the tools to solve it. Very fortuitously, just a couple of years before Amazon set out to build the Alexa technology and the Echo devices in particular, just a couple of years earlier, there had been a breakthrough in applications of deep neural networks, sometimes called deep learning, to speech recognition. And this was a new and different way of characterizing for what we call the acoustic model, meaning that part of the system that recognizes what sound of the language it's hearing, that can tell the difference between an ooh or an ah or a sh or a p or whatever, the different sounds of the language. And the previous approaches were kind of brittle in that respect, that if it was getting, they had a hard time representing the variety of sounds that you might get when you're getting these, echoey, reverberant, muddled copies of the speech signal bouncing off of surfaces in a room. But these deep neural network models were revolutionary and allowed a lot better modeling of how to recognize those sounds. And as long as they had enough data to feed them, as long as you had enough data to say, here's what these sounds, here's what these are going to sound like within a room, they were able to capture that, and you were able to model that with these deep neural networks. So that's the one thing that was a prerequisite that had fortuitously just come along just a year or two before. Well, maybe 3-4 years before, but pretty close before. And so then the other piece that we had to do to take advantage of that was to go collect a whole bunch of data from people speaking in rooms. And we had to capture every conceivable kind of room. We had to capture offices and bedrooms and living rooms and kitchens and bathrooms and garages and whatever else. And so at Amazon, we had a very ambitious data recording project. And of course, this was doubly hard because it was all done, the project was so secretive. We couldn't really tell people what we were doing, but we collected recordings of many thousands of people in many hundreds of settings of different rooms and so forth. And we're able to then feed these deep neural network training algorithms all of this data and let it learn how to recognize this reverberant speech. And so that was the first key, which we solved with these two sort of joint techniques of using deep neural networks and lots of data that was collected that captured all of that.
Yeah, very fascinating.
So that's the one piece. There's another piece that when you say to me, okay, I want to be able to ask my Echo to play any song that is in Amazon's catalog. And there were more than 1 million songs at the time. It's more now. But at the time, there were more than 1 million songs. And they all had a lot of interesting words in their titles, some interesting spellings and so forth. And we had to figure out, okay, how to make, I'm just using the music playing as an example, but the same thing applies to asking for weather in random cities and whatever. We had to teach Alexa a huge vocabulary of words that would be able to capture every song and movie and city and whatever that you're speaking. And in fact, she has to know more vocabulary than a typical human does, because most humans don't know the names of every city and all the words in every song and so forth. And so we had to teach her a huge vocabulary and the language side of it, of how to ask for these things and so forth. So those two pieces together, this acoustic modeling, which we tackled with deep neural networks and this data collection, and the language, which we captured by doing some very sophisticated language modeling and putting those together, that allowed us to really tackle the speech recognition problem that went into Alexa. Now, we sometimes call out separately the wake word part. The wake word is just a specific instance of speech recognition, but it's challenging in a couple of ways. First of all, it's challenging because it's got to be the wake word is like the sentinel. It's guarding the entrance to the whole rest of the system. You've got to get it to recognize the wake word. In most cases, that is Alexa with Amazon, but it might be a different wake word for a different system, and you can change the wake word on your Alexa device as well. But it has to be able to recognize that in a very robust setting. And I don't know if everybody understands this. There's a small recognizer on the device that's running on the device that is just running the wake word recognition. So on my little Echo my Echo device at home, I When it's listening to me speak all the time, unless I've muted it, turned off the mic, but it's listening to me all the time. But it's not sending that up to Amazon until it hears a wake word. But that means it has that job of this little tiny device on a cheap chip has to recognize the wake word flawlessly in order to then pass it along, pass the speech along to Amazon.
Well, and with that too, I think that's at the core of the misconception that sometimes runs in the mainstream, news media, where
Yeah,
it's this notion that it's always recording and it's always listening, and it's such a misconception because, to your point, it's just listening for the wake word. It wouldn't really. Can you speak to just like the feasibility of how it would be ridiculous, right? If it were literally the whole system was listening all the time,
yeah,
the power consumption and the
yeah. You can't run that many computers to to
right.
to listen to every device 24/7 in some cloud-based system. So that's why the devices have to be the gatekeeper, and the wake word is the gatekeeper to say I have to say the device, and then I will send that next utterance up to the cloud. Um, Sometimes, I can't remember what it was, but I was talking to a rental car company and I said, okay, yeah, I'd like to see Alexis, and
Yeah.
Alexa woke up thinking it heard its name. Well, sure, we all sometimes hear our names when someone didn't really say them. But then it quickly says, oh, okay, the thing that followed that didn't make sense. So it might have sent it up to the cloud, say, hey, can you make sense of this? And the cloud says, no, I don't make sense of that. And then,
Hmm.
but so there are some utterances that will go up to the cloud, but they're few and far between. And the idea that anybody's listening to you is just preposterous.
Yeah,
And it's not feasible. It's not practical.
that's what I thought.
Yeah. So the wake word is running on the device, and it has to be a low power thing that's always listening. The speech recognition, then once it passes it up to the cloud, is going to make sense of the words that you said. So if I said something like, I want to hear some reggae, um, it's gonna pass that up to the cloud, and the cloud has to recognize those words. I want to hear some reggae. Now we're done with the first two of your four uh, bullets there, right? Now,
Yep.
now we've heard these words. I want to hear some reggae, and what are we supposed to do? Are we supposed to turn on the lights? Are we supposed to, order you something on Amazon or whatever? No, in this case, we have to recognize that means I want to play some music, and specifically, I want to play some music that has the genre marked as reggae. It's not reggae isn't referring to an artist or an album name or a song name or something like that. It's referring to a genre, and it takes some intelligence to figure that out. What do you mean by, I want to hear some reggae? How do you turn that into an actual command that the system can act on? And that's this third bullet, the natural language understanding of turning a phrase or a word, a command, just knowing the words, turning that into understanding what am I supposed to do. And that's challenging. I honestly think at Amazon, and when we first released it, I think the speech recognition was more accurate than the natural language understanding. When it made mistakes in those early days, I think it was more often because the natural language understanding fell down and wasn't able to parse whatever it
Mhm.
was that you said. But that has changed dramatically over the last 5-6 years, and the natural language understanding is super powerful now. I still sometimes find it making mistakes for me, and I'm sure we all do, either mistakes on the speech recognition or on the natural language understanding. But that's what the natural language understanding part is, and it's got to figure out what are the things that you're talking about, and what are basically it comes down to understanding verbs and nouns. So it's got to understand the verbs, meaning what do you want it to do, and then the nouns, what are the things that you want it to act on. So when I say I want to play some reggae, it needs to understand the verb that means, okay, play some music. And then it needs to understand, that the word reggae means a style of music or whatever. And that's challenging. It's a hard problem, and there were some primitive NLU kinds of systems at the time, but with Alexa, we had to like really advance the state of the art there to be able to understand a broad array of things with a large collection of cities, or as I mentioned, cities or song names or whatever. And then the final piece is once we haven't, if someone asks a question or if we need to respond to the user and say something back, we want that to sound natural. And at the time when Alexa was first unveiled, a lot of people remarked that her voice was remarkably natural sounding. I mean, it still is. I think Alexa sounds great.
Agreed.
But that was not easy. If you remember back to Stephen Hawking's text to speech voice or whatever, we've come a long way in recent years, and that work was done primarily by an outstanding team in Poland that was acquired by Amazon. And is now Amazon's text-to-speech team, and continues to improve the naturalness of the voice, which, as I say, I think is remarkably natural. And other cool features like, I don't know if you've been following, but you can pay $1 and get Samuel L. Jackson's voice to be your voice on Alexa. And I think that's pretty cool too.
Yeah, no, I totally agree.
So anyway, those are the four big areas. They all required really groundbreaking, aggressive work to get them to work well. And I look back on what we did at Amazon. When they first told us what they wanted us to do, they thought it might be 6 months to a year kind of project. And it ended up being a 3-year project from the day they unveiled it to us until we launched. It was just a few days more than a year, than 3 years.
Yeah.
And that was with a really impressive and large team. There were hundreds of people working on this, on the TTS and the ASR and the NLU, and sorry to use all those three-letter. It was a fun and heady time for me.
Yeah, no, I appreciate you sharing all that. And I have a few follow-up questions on a few of these different ones. My first question is, can you kind of like recount that day that Jeff Bezos pitched you on this? And I'm just curious, was this, because I feel like I've heard conflicting stories at this point, was this initially his idea of the end goal, or do you know the origin of how Alexa was conceived?
I know a little bit about it. First of all, I'll clarify, Jeff Bezos himself was not in the room, did not personally pitch it to us.
Okay.
But he Jeff Bezos at Amazon at the time, I think it's still probably the case. He has like a right-hand man or woman that goes with him to a lot of meetings and is called his TA. And his TA had been a guy named Greg Hart, who he and the two of them had a lot of discussions. They had heard a lot of ideas, and they heard a number of things that over the course of a year or so, a lot of things that kind of made them start thinking along the lines of a voice first home personal assistant speaker, smart speaker, like the Echo. Nothing like that existed in the market, right?
Yeah.
And they heard a number of things that made them think that might be an interesting thing. And so when Greg Hart, this TA, finished his term, he then took over the leadership of the Alexa project, and he was in the room. He was the one who pitched this to us, and so, you know, I don't know. I wasn't there in those meetings with them. I don't know exactly what prompted what, but they were, you know, it clearly was a product of discussions with Jeff Bezos, Greg Hart, and maybe a few others that led to the concept of the Echo.
Yeah. Okay, that's very interesting. And I know that you mentioned the two different. You said in this podcast, you said it was sort of a stealth project that you guys were working on. But I know in a previous podcast of yours that I listened to, there were dueling secret projects at the time. It was the whole Alexa project, but also the Fire Phone. And I thought it was really interesting. You said on that podcast that I listened to that the insider talk was that everybody was kind of bullish on the Fire Phone, and it ended up, you know, sort of fate would have it that it went the other way.
Right. Everybody thought, oh, the Fire Phone, that's a solid bet, and and no one, there was no such thing. I mean, there were phones already, right?
Mm-hmm.
There weren't smart speakers already, and so people just weren't sure if that would catch on at all, if they care about a smart speaker. And so, so the Fire Phone project was our sister project. I say that most people working on either the Fire Phone or the Echo, the vast majority of people working on either one didn't know about the other. But
Mm-hmm.
the management levels, there was some discussion, and people generally the talk on the talk at the time was that the Fire Phone was going to be the big thing.
Yeah.
You know, and the Echo was a big risky project. No one knew if it would go anywhere.
Okay, so the next question I had when you were going through the four different things, something I've thought a lot about around wake word detection is, okay, so if we're moving toward the scenario where somebody in their home, they might have 5 different devices, 5 different Alexas, and let's just say I'm in some area that could be considered, you know, I'm in my bathroom, has a wall, it's got an outlet, you know, a plug that has Alexa in it, and then I have a smart speaker in my living room or something like that, and I'm right in between the two. How do you envision this working where you'll be able to they'll work in simpatico almost, but that they won't compete, I guess, or both be kind of responding to you?
So that's already the case, that they try to coordinate among themselves to figure out. And the main thing they take into account, I believe, I have to say, most of this work was done after I left Amazon, so I don't have any inside information here. I'm just guessing as an educated observer from the outside. But I believe that what they do is they look at the volume, and so when I say Alexa in my house, I have a half a dozen devices, and they all they're connected enough to be able to compare notes, and one of them will say, oh, I heard that the loudest, and the other, okay, you take it over, because you can set up your devices like as part of a room. So when I walk into a room, I can say turn on the lights. It knows, oh, this device heard me, and so I'm going to turn on the lights in this room, as opposed to if I walk in another room and say turn on the lights, it'll turn on those lights in that room, because they can tell which device is hearing me. But sound is a weird thing, and very often when you speak, as I say, things, sound bounces around the house, bounces off walls, and very often my voice is heard by, at least I'm speaking from my personal experience in my home. Very often if I say, sometimes I'm in the kitchen and I'm not particularly close to my kitchen echo, and I say, Alexa, start a timer for 5 minutes. And sometimes oh, I just said that. And I just heard Alexa start a timer for 5 minutes down the hall in another room. I don't even know what one that was. I muted the one here in my office. But sometimes it'll hear me in another room, and it'll start the timer on the wrong device. That's just because they got confused about being able to decipher which one I was closest to, which one I probably intended to be talking to. But they're getting smarter about that. Alexa is starting to take into account context of like, he usually sets timers in the kitchen, not in the bathroom or whatever. So
yeah, interesting. So using a little bit of contextual information.
Exactly, starting to take that into account.
So I think that's great, because I think now both myself and hopefully the listeners have a better understanding of like the actual inner workings of these devices and how we sort of are able to operate them in the way that we can, and just having a better sense of how sophisticated these things really are. And so what I would love to now focus the conversation on is, okay, so where we are today, I would love to hear, focusing this on coronavirus. So can you share with me some of the different ways with the technology in its current state, how we can maybe use it in some capacity to either support, augment, or even kind of combat the disease in some capacity?
Yeah, sure. So we've been talking a lot about Amazon and Alexa during this conversation, but honestly, that was 5 or 6 years ago. my current life is working with companies that are trying to do other creative, interesting things with speech technology. And we have a group that we're talking to right now to develop screening kiosks where when you're like entering into a workplace or a public space or whatever, that instead of having a person that has to ask you all sorts of health questions like have you been exposed to this, do you have a cough, what's your temperature, whatever, I don't know, whatever they might have, that this little kiosk will just interact with you by voice, and rather than having to like pick out on a keypad the answer to a question, you can just speak naturally to it. And so we're trying to get that set up to get rolled out in places like I say, like places of employment where people still have to go, even during this general quarantine time, but also in airports or other open spaces, public facilities. And so we're working on that. Now, that's just simply, being able to have a conversation with someone about a directed topic, in this case, health questions. There's another level of this, which I find much more fascinating. And that is the idea that a lot of diseases, including coronavirus, they affect your speech itself. Yeah. So with coronavirus, it affects your ability to breathe and how deeply you can breathe. You run out of breath. You'll speak in shorter utterances. You'll have to stop and take a breath. You might have a rattle in your lungs. Anyway, there's a number of things that might affect your speech. And the question is, can we spot those automatically? Can we listen to someone speak and say, oh, that sounds like they might have coronavirus, and do a sort of a first level, really easy, cheap screening that can be done just on a tablet or something, instead of requiring a kit, whatever, and someone could do it from home on their phone or whatever. So we at Cobalt have a sister company called Canary Speech that focuses generally on diagnosis and evaluation of disease conditions, neurological conditions, things like that, which include things like depression, mental health, Alzheimer's, Parkinson's, a variety of conditions. But we're also now with Canary, Cobalt and Canary and others are looking at developing techniques to be able to detect these biomarkers that might indicate that you have coronavirus. It's very early days. We're involved in collecting some recordings of people with and without the disease, and we're just sort of picking through that data right now. And ask me in another 2 or 3 weeks whether we've been able to make some progress on that. But I'm hopeful that we will.
Yeah, no, I think that's what's so interesting about this is you made a comment when we first started this conversation about how you sort of almost needed a prerequisite. You needed like these underlying technologies to have matured to enable the Alexa series of devices, right? You needed like the deep neural networks and all the advances there. And I think what's interesting is in order to do a number of the things that you've just described, whether it just be solid ASR and text to speech, in order to do sort of the triaging and the kiosk work, you need to rely on the last 5 years of progress that's been made. And then obviously with Canary, it's to a whole nother level of sophistication with that. Do you imagine that like in the foreseeable future, as this matures, that you would be able to ask a consumer device, whether it's an application that's being powered on your Alexa device or some type of device that you'd be using the Canary app, or you'd be using the Cobalt app, where you can, in the Canary scenario, where you can literally say, hey, Alexa, or hey, Canary, do a diagnosis on me today. And it will have you do, a minute long, you'll recite something so that it can collect a sample. And then from there, it will be able to read the biomarkers in there to at least get a sense of maybe there are some things off because you've been performing this and you've more or less established a benchmark of what looks normal in your data because you do this kind of every single day.
Right. And in fact, we're already at Canary, we're already doing that for a number of conditions. The challenge is adding new conditions. We need data for that to know what it sounds like to have this or that condition. But we're already doing that at Canary, working with a number of partners to detect, identify, diagnose early signs or biomarkers for a number of conditions.
So can you share with me then, like, what are, based on your experience at Cobalt and some of the different projects that you're working on, can you kind of shed a light on where do you see this, like voice assistants in general, and this idea of using them for more and more complex scenarios? Where are the limitations today, and what are the things that give you the most hope in terms of, whether it was with deep neural networks 5 years ago, maybe it's still with deep neural networks and deep learning, but I'm curious to kind of get an idea of like where we should be looking in terms of areas that are going to help to support the momentum of continuing to move this further and further along so that these voice assistants are just increasingly more and more capable.
Yeah. So I think these are going to become more pervasive. You're going to find them in more places, in your car, in your refrigerator, in your whatever. You're going to find voice
everywhere.
Right. Yeah. But in order for that to work, there's something that's kind of missing. I'm really proud of what we have done over the 25 years that I've been working in voice, to be able to bring it into the mainstream, get it to work for more people and so forth. But it still doesn't work for a lot of people. There are a lot of people who have distinctive accents or speech difficulties, or there are people that we don't understand exactly why, but they just don't get along with speech recognition. We in the field, we sometimes call them goats, and I don't mean to say that as an insult, but it's just, there's this phenomenon of speech goats that the technology doesn't work for them very well, and we don't always understand why that is. That we're getting there. We're getting to where there are fewer and fewer goats, but there are still huge problems that that we have. Like, if you look at everybody in the world, there are a lot of languages spoken, and only a fraction of those have any kind of speech technology to support them. So there are lots and lots of people around the world who have a cell phone but can't talk to it. And for them, if they see, in a movie or whatever, they see someone talking to their phone, that's science fiction. That doesn't work for them. They aren't in that world. And we want to bring them into that world as well. That's one of the things that I think is going to have to be on the forefront of our progress over the next 5 or 10 years, is being able to bring this technology everywhere. So it's not just speech everywhere like a lot of devices in the first world and second world, but also throughout the world.
Right.
That speech is everywhere for everybody.
Mm-hmm. Yeah. It's as accessible as possible too, not just as available. Okay, so that's really interesting. And then on, something like, because where I think my lack of understanding starts to fall apart is the deep learning, the machine learning. Can you just speak a little bit about the current state of things and where that area is sort of going?
Uh, so deep learning refers to a very specific type of machine learning. Machine learning is a broad category. Deep learning is a very specific type of that
Mm-hmm.
uses multi-layer perceptrons. That it's a very particular thing that happens to be very good at recognizing images and speech and a number of things. That technology is becoming mature. There have been several variants that have been explored and refined, and we're getting pretty good at least the. I don't know that deep learning itself is going to improve a whole lot. It may find new homes. So, for example, deep learning is not used. It's used a lot in acoustic modeling. It's not used as much in language modeling, and even less in like natural language understanding. So the deep learning approaches might find new homes, new places to be applied. So that could happen. I also think that there are going to be things that surprise us that we don't know. I mean, deep learning surprised us 10 years ago. I don't know. I don't know what the next surprise is going to be. But I look forward to it, and I hope that we're smart enough to recognize it and capitalize on it. The thing that I have learned, if I've learned anything in my 25 years in this field, is that the future is just not knowable.
Yeah.
That you can see a little ways down the road. You can take some educated guesses about what's going to happen 6 to 12 months from now. But as soon as you start talking 2 to 3 years from now, there's just too much that is unpredictable, and things are going to impact it beyond the technology. The coronavirus thing is impacting our lives in crazy ways that we wouldn't have predicted, and that are going to spur new developments and new product and applications. It's getting people used to working from home. Who knows how that's going to change the world? There's just a lot of things a lot of ways in which the future, I don't know how it's going to evolve.
Yeah.
But I hope that, like I say, I hope we're smart enough that when opportunities present themselves, we can jump on them and take advantage of them, and don't let them pass us by.
Yeah, no, I think that's really well said. And I think from somebody like you that's been working in this space for as long as you have, to acknowledge that it's really hard to predict where this is going. You have a sense of what options it enables, but you don't necessarily know where it's ultimately going to go. So, Jeff, as we wrap here, can you just share with the listeners a little bit about where they can find you, contact you, and just read up on Cobalt and the great work that you guys are doing there?
Yeah, you can find me hiding out in my house. No, seriously, you can always get a hold of us at Cobalt. You can go to our website. There's a contact us button. You can send an email to info@cobaltspeech.com. You can follow us on all the social network things, and we're always happy to hear from people, especially if you have some interesting ideas for projects that we could do with you.
Yeah, yeah. I mean, I got connected to you through Bruce Russa, who is with Ag Voice. So I'm going to have a podcast episode coming out with him in the not too distant future. But another company that you guys are supporting.
Yeah.
So I love these sort of white label voice assistants that are being specialized for different verticals and industries and stuff. I mean, to think that this is just limited to Alexa or Google Assistant is not understanding the full picture, because I think the most interesting stuff is actually happening sort of in these really narrow but deep verticals.
Yep, I agree.
Well, cool, Jeff. Well, thank you so much for tuning in this week, everybody. And thanks, Jeff, for jumping on. We will chat with you next time. Cheers.
Thank you. Bye.
Okay. So you can just stop recording now.